This is Prompting from Responses to Adding to Diarization, the project report by Shoham Weiss and Ted Dang. The two group members that worked on this part 2 of the project is Shoham Weiss and Ted Dang. We would meet weekly, and we have all of our documentation on Google Drive and all of our code on GitHub. The goal of this project was to have Hannah, which is our user in this case, be able to communicate with multiple people at once and even interrupt people mid-conversation rather than have to click start record and stop record only when people are talking directly to her. To do this, we have to figure out everything that's going on in the environment, as in who is talking to who, even if they're not specifically talking to her. This problem is called the diarization problem, where you can have multiple people speak and we need to figure out who said what. To split the project up, we started with researching diarization, and then we designed the API, and then we coded the API, coded the client, integrated, and then have a final output. Our project architecture consisted of code, data, and platform. The platform we mainly used for everything for our code was GitHub, where we have our client code and we also have our API code in one repository. And then we also have the data as the client runs is actually in the browser. And then we download the models from Hugging Face. So we use two models from Hugging Face, the audio diarization model and the audio transcription model. Now we'll get more into that later. The main process that the system needs to go through now is you have on the left a group of speakers, speaker 1, speaker 2, and speaker 3, all talking to each other and maybe also Hannah. And then the diarization model needs to figure out who said what and then convert that speech to text of who said what, because we need it to be tagged. We get times. We get from this time to this time this person spoke, and from this time to this time this person spoke. So we grab those chunks of time and transcribe them. And then we provide that as a conversation for the system, and then using that conversation object, the system can use the 3 models made in the previous project to create options for Hannah to choose from to speak, or she can manually type. And so in that system we have the client, which is on the browser, which every X seconds, which we found out, turns out doing every X seconds works pretty badly, and having her click transcribe will work a lot better. But every time we want to transcribe the audio around us, we send this audio to the server. The server initially already has downloaded all the models that it needs to run, and so it runs the diarization and transcription on that audio and responds to the browser with the conversational data. And then that browser again will call the server asking for suggestions, and that's from project 1. This is the more detailed description of what's happening that I just went over. Note that the API receives the audio, runs diarization, and then transcribes the audio snippets, and then responds with diarized transcribed data. One main thing that we added in this iteration is running everything on Google Colab. Because we are running 5 different models, machine learning models, it's getting very heavy to run locally. And so Google Colab provides GPU services for us, and so what we did is we pull the GitHub repository that contains our API into Google Colab. We open that notebook up to the internet using ngrok, and then we run the API on our Google Colab, and I will demo this in the next slides. And this is the next slide. So now I will demo. So here's where our API is running. This is a Google Colab notebook, and then in this cell we're running Python API.py, which is our API Python file that creates an ngrok tunnel right here. And then we can talk to this ngrok tunnel to talk to our API. And so the UI right here has an option to decide what the API endpoint is, and so we paste our ngrok API endpoint. And then we can make use of this to run all of our models. And we can also put information in the about me. So my name is Shoham. I like the color green. So let's start having a conversation and see how this can help us. Hello, what is your name? You can see I click transcribe to get the response. So I stopped recording so I don't keep recording my explanation of what's going on here. And you can see here I have hello, how, Mandy, my, Jay, nothing, and Shoham, which is my name. So I'll just say Shoham, and then I'll say
Shaham.
And then in this case, the person would not stop record to explain what's going on and click record again, but this is just for the demo. And let's say we continue talking and let's have multiple conversations happening. So, Shoham, that's a nice name.
Good.
What is your favorite color, Shoham?
Green.
Oh, that's my favorite color too.
Oh yes.
So you can see this is not working perfectly, but it is functional. Every time you choose one of the blue responses, the model will try to suggest a next word option. This is a conversational model that if it has good input to give you, it'll give you a whole conversation sentence to say. The main issue we're running into here, because we ran out of time, is the way that the model on the server side transcribes the speech is not very good. As you can see, not as good as Microsoft's built-in transcription, which is this one, which is separate from the transcriptions you end up seeing here. Because of that, the models will perform slightly worse, but it's still very functional and needs improvement, but works. Lastly, I'd like to show a conversation between two people that's pre-recorded to show the diarization process.
So, Aaron, in your email you said you wanted to talk about the exam.
Yeah, I've just never taken a class with so many different readings. I've managed to keep up with all the assignments, but I'm not sure how to
review everything?
Yeah. In other classes I've had, there's usually just one book to review, not three different.
As you can see, the audio is transcribed well and split by the person who said it.